for joining this call today. We are going to talk about your first smart contract in Rust and Vara network ecosystem. Then let me explain a brief introduction about myself. My name is Luis Ramirez. I'm from Mexico City, and I'm actually head of the DevRel at Gear Foundation. I work mainly with developers just to teach about the technology, and also I participate in different kind of hackathons, different countries in Mexico, Latam, and also in other hackathons, ETH and Polkadot hackathons. So the last 2.5 years, I've been involved in this kind of events. Then that's why we are here today. Also because we want to explain the magic behind the technology of our network creating smart contracts. So please meet the Gear Foundation. It's a decentralized team, more than 60 people passionate by blockchain technology. You can see here a picture of one of the events in Turkey. No, yeah, this is in Thailand, and yeah, we met Montenegro. This picture is from Montenegro, and as you can see, we are people in different countries, right? It's a decentralized um, foundation. Then there are people from United States, Mexico, Turkey, Spain, China, and all other different countries. The Bar Squad performs different events in countries like Spain, Mexico, China, Turkey, and different countries. We used to provide information about blockchain and the Bar network ecosystem. So maybe we can perform one event on your country. Just let us know, and we will be there. Let's start with the information related to the smart contracts. Yeah, because this is a smart contract workshop. Then, first of all, we need to understand the basics. What is a smart contract, and what is the difference of what we are doing in Vara network? Smart contracts are equivalent to microservice in Web 2 ecosystem, which normally when you enter into a website and you log in and you use different features of the website where you are, you get information from a centralized server, okay? Then this is normally work on the backend side, the part that you don't see, by a web server providing microservices. Then you can see that a piece of code is executing one part of the thing that you want to run on the server side, and you get the result. Okay, that's similar what a smart contract is, but in this case on Web 2, the blockchain ecosystem, you can see it as a piece of code that is inserted into the blockchain. Then it's immutable, and with this in mind, then you can trust that the code is going to do what you want to do. And also it must be open source in a real decentralized network, so the users that interact with this piece of code, with this smart contract, they will realize, understand, and make sure that the code, it does what it does, because they can read the code. It's open source. Okay, then, okay, this is a smart contract, and it depends on what your smart contract do, is the name of your app, just the category where you are trying to create your application. We can say, for example, the decentralized finance is one, when you want to interact with user. If you want to enter into a lending platform, for example, if you want to gain rewards of that lending and something like that, you are entering into a kind of decentralized application called DeFi. Okay, so in this way you can do different kind of applications. ERC20, ERC20, the standard token in all the networks, NFTs, which provides the ownership of this token. You will be the owner, and you will have a way to prove it. It's created a digital certificate inside the smart contract, and it's a better way to prove. For example, it's used normally as profile pictures, but also it's more powerful because you can use it in a supply chain integration. So you will have different kind of steps with NFTs and other different applications and other different use cases. Okay, and then if we understand that every piece of code has a name, has a category, then once we want to create something into the blockchain ecosystem, we need to focus what is this application, and we need to concentrate in why blockchain will provide something different than the normal centralized ecosystem. This is really important once we create this. Okay, before to start what Vara network does with the blockchain ecosystem, talking about the smart contracts, we need to understand the way that it works, and this way it will be easier for you to understand the smart contracts. This application, the decentralized applications, works into the blockchain, which is based on the consensus mechanism. It depends if you are working on proof of work or you are working on proof of stake. This consensus mechanism interact each other between the nodes that form the network, and ensures that the transaction and all the information contained into the network is real, and no one can modify this. That's the powerful of the blockchain technology. Then also we can implement different use cases on this kind of ecosystem. Then we need to understand why a new network, because this is the first question a developer asks when you met a new technology, right? Then something important to understand is that Vara network is a young blockchain, but with a lot of experience of the people that create this technology. We can start with Nikolai Wolf, which is the current CEO of Gear Foundation. In the past, he was working at Parity Technologies. This is the company behind the Polkadot technology. But with the experience that Nikolai had, he realized that it was possible to use framework that was created at the moment that he was at Parity, called Substrate. It's a framework to create modular blockchains in an easy way. Then it was possible to create a blockchain based on this framework that will provide different things. For example, the first one is a powerful API, an easy API, just to bring Web2 developers into the Web3 ecosystem. And this is really important because one of the biggest challenge in the blockchain technology is the adoption. When a developer wants to interact with blockchain, the developer starts typing into Google or whatever browser, what is blockchain, how to create my first program on blockchain, right? So a lot of information comes. You need to learn this programming language. You need to use this platform. And this is right now blockchain when you want to enter as a developer. A lot of tools, a lot of programming languages. And one of the important thing in Vara Network is that we use something called WebAssembly. We will learn more about this technology. But I want to explain this part because this is a key feature of the adoption. If you develop on different kind of programming languages, then you will be able to create smart contracts for Vara network. And that was one of the ideas that Nikolai had creating this powerful ecosystem. And well, after the time, this technology started to be open source, and now everybody can be part of this incredible technology. So the the contracts, the templates, the node, different things on the ecosystem, you can just enter into GitHub and check, download, compile, and upload. Because it's open source, then you can improve if you want it. You can send a PR if you believe that something better may have this technology. Okay, then we understood that the technology behind Vara was created to bring adoption, one of the key features. And something important on the technical side to understand is the pillars. Because, yeah, okay, the adoption is a focus, but what is the stack? What is the more important thing behind Vara Network? And we can say three different things. The first one is the actor model. Everything in the ecosystem is an actor. So in this way, you can interact between all the applications and users as an actors, and they can send messages to each other. This is really powerful because sending this kind of messaging system, then you will be able to interact with different smart contracts, and the smart contracts can interact each other, just sending and receiving messages. This is the powerful behind actor model. Let's talk more about WebAssembly. WebAssembly, as I mentioned before, it's a technology, but it's a binary format that will help you to run an application in a faster way. And you can create this application in different programming languages, more of 22 programming languages like Rust, C, C++, Assembly Script, Java, Python, and different others. So far as we speak, Git protocol supports Rust and assembly script. Okay. And WebAssembly is also important because it enables the feature called forkless. So all the technologies, all the blockchains that implement this incredible technology, their runtime, it's created inside the blockchain. So you can modify it, you can change it in runtime using WebAssembly. No, you don't need to stop the network. You don't need to fork the network. You only inject the new binary, and the update system will interact with the new binary. Okay. And on the other hand, the last but not least is persistent memory. Every smart contract has its own state. It means that you cannot access, for security, and this is really important, you cannot access to the state of other smart contracts. Then you can interact only with the state inside your smart contract. And this is important, right? And we use the persistent memory once inside the smart contract, the developer wants to persist information into the blockchain, into the state. Then this implementation use different virtualization techniques just to make it possible, because considerations of the internal technology stack uh, tells that you need to use every 64 kilobytes every memory page, for example, and you need to manage these pages in order to read, in order to write, and well, the persistent memory implements all these functionalities, so the user at the end won't worry about how it works inside. You will only use it. Okay, you will see once we start with the smart contracts with Rust. So Vara Network, we can say, is a sovereign layer one built on Substrate, as we mentioned before. Simple, powerful, just to create a really huge and secure applications. It's a next-gen cloud infrastructure platform. Yeah. Then, if we understand that it's created with the latest technology, with the evolution of the technology in the past since the Ethereum was created. After the time, we have all this stack, we have all this information, and that's what Vara network is. The evolution sovereign layer one provides an easy API for the developers, so you can come and create your smart contracts in an easy way without worrying of understanding different other programming language. That's why we avoid the domain specific language. If you know Rust, it's gonna be really easy to understand how to create a smart contract. If you don't know Rust, maybe you know assembly script, you can do exactly the same. But if you don't know all these languages, but you understand C, C++, Java, it's gonna be really easy to understand the basics of Rust to create one smart contract in Vara network. This is one of the powerful things behind this technology. Okay, and in the Vara network ecosystem, there are different ones, different distinctive features, but I want to provide information about the latest three, more powerful, I will say, for the developers, because you can interact with the smart contracts in a different way and provide functionality for the end users. At the end, it's going to be easier for them. At the end, it's going to be faster. Then we need to explain three things. The first one is delay message. Delay messages are the part when we send messages in an asynchronous way. All the messages that we send in the Vara network ecosystem are asynchronous, but we need to understand that delay message has one timeout inside of the message, and that means if a contract send the message to another contract, then we can just wait for this timeout before the another smart contract process this message. Okay, this is something nice, but just imagine that you want to create a full on-chain application and you want to evaluate every week one status of your application. Like if, for example, if the user has paid the membership of this application, like a live streaming platform or something like this, then this kind of evaluation you can implement it with delay messages, because you will send a delay message with the timeout of 1 week, and this timeout it's some blocks, right? So you just need to do the calculation how many blocks will have 1 week, keeping in mind that one block in Vara network is closed in 3 seconds, right? Okay, a really powerful feature that you need to keep in mind to create a full on-chain applications. Okay, on the other hand, we have payless transactions. Payless transaction is a really incredible feature because you as a developer, as a smart contract owner, you start with your application and you will think, okay, I'm ready to upload my smart contract into the blockchain, but I'm not quite sure what is the best way for my users to interact with my application, because they need to get tokens. They may ask into the community where can they get tokens, and this could be a problem for the first users. Then payless transactions is the feature that will help you to bring adoption, because inside this system we have something called vouchers, and a voucher is a digital space into the smart contract where you can send tokens for your smart contract for one different users to interact for free. It means that you as a developer, you can inject the tokens and avoid that the user pays the gas fee on its own. Really powerful feature, right? And let's talk with the third signless transaction feature. It's okay. If you have interact with the Web3 applications, you will notice, or you have noticed, that you need to click every time you sign a transaction. This is for security reasons, of course, because the application needs to be sure that the end user is the owner of the account, then you need to sign every transaction that you send into the blockchain. But here, if you implement signless transaction, then you can create a trusted session with a key pair. You don't need to create it. It's created when you implement it. So when you implement signless transaction, a temporary key pair is created, private and public key. And with this temporary account, you can just interact with the smart contract and avoid that the user sign the transaction every time that he or she is using your application. Nice, right? Then just keep in mind this, and to make it everything in one space, signless and payless transaction together is blow mining. So signless transaction bypass the need for digital signature from the user. Payless transaction, as I said, avoids that the user sign the transaction every time. Sorry, avoids that the user pays for the gas fee of its own. Then they will use the vouchers, the tokens that you already have on the smart contract. And you may think in different use cases, it will be really powerful if you implement your application with this feature, because at the end it will be really seamless application, just like a Web2 application for the end user. Okay, this has the information related of what is the mechanism both in signless and payless transaction. And as I said, the signless transaction with smart contract logic validates a user without signing the transaction every time that is interacting, and the payless avoids for the end user to pay the gas fees, right? Okay, now if you are on your computer and you are ready to create your first Rust smart contract in Vara network ecosystem, let me explain you something first before you start. We can see here on the right an image about the smart contract, and it starts with the metadata. Okay, do you remember I told you that the contracts are able to send and receive messages? Okay, then how they will understand what information you are sending? For example, if you send to a smart contract information related to mints and NFT, how the smart contract will understand the information that you are sending? Well, this mechanism, this part of the communication where you need to explain what data type you are using and what is the size of this data type, is a metadata, because it's a way to convert raw data into human readable structures. and and this way you can just create structures of integers, strings, and different other data types and sending it to the network, so the metadata will contain the information related the data type that will be sent and received. This is really important. Okay, now once the smart contract is on the blockchain, it's important that you initialize this smart contract. So we use the init method. But the init method is used only once in the life cycle of the smart contract. Okay, and you can use it if you want to initialize your state. But if you don't want or you don't need it, this method is optional. Then don't implement it, it's okay. But if you have something to do before to start the functionality of your smart contract, before to receive messages, then the init method, it may be helpful for you. Okay, and the state is this part once you want to persist information into the blockchain. Like the state is the more important thing related to what will you store inside your smart contract. And just remember that the state is unique on every smart contract. So when you interact with your application, you will be sure that this state it's unique on your smart contract space. Okay. Well, in the bar network ecosystem, there is something interesting called meta state, which enable the user to read information from the state for free. Normally, on other different blockchain ecosystems, if you want to interact with your application, and just because you are executing some kind of transaction, of just because you are performing some calculations, you need to pay gas. Here, if you read the state, the user won't pay anything. It's free. Then this is really a powerful feature, because you avoid to increase what the user will pay when interact with the smart contract. Okay, just keep it in mind, and we will use it in our example, creating one Tamagotchi smart contract. And at the end, okay, my smart contract is ready, but I need to code what the smart contract will do, right? This is the business logic. The business logic is the part where you describe with details all the different events that your smart contract can manage. Then, once the smart contract is in the blockchain and receives a message, then your smart contract will be ready to interact with your events and execute what you are describing inside of each event. Okay, the main method for this is the handle. So the handle is the method where you implement all this functionality. And if you want to answer to one smart contract that call it, you can return the information, and on the other smart contract manage the handle reply. Okay, now we are ready to create our first smart contract, but let's think about this. You can create one smart contract, and also you can create another smart contract and interact each other. This is a really powerful feature in the Vara network ecosystem, because we don't depend only on the user side to interact with the smart contract. One smart contract is able to call another smart contract through messages. That's why the implementation of actor model. Then all the messages that we'll send between each other will be received by the handle method. Okay, just keep in mind this, and we will see a nice example. So we are ready here. We're gonna open a new tab. Just I want to make sure that you see my screen in this repo. Let's check. Let me open it, and I'm gonna see. Okay, I need to stop a little bit my presentation, and I'm gonna share it with my other screen. Okay, now we can see the screen. Here you have the repo. I'm going to explain with detail what is and what is the structure of this repo. But you can see it's a Gitbot, and it's open source, so you can go download, modify, and do whatever you want with this smart contract. Okay, and let's click open in Gitbot. And this is a platform that you can use to create and modify code without downloading anything. You don't need to start the environment. You need to configure your environment on the computer. You just need to enter into the application gitbot.io, and you will be interacting with the GitHub repos. Okay, just let me show that you can see here. Okay, perfect. Let's dig deeper into the structure of our smart contract. On the left side, we have different directories. Let me explain the more important ones. Do you remember I told you about the metadata? This part that interacts with the information that you send between smart contracts, or a front end and the smart contract. Well, this is implemented here in the IO directory. So we can see here this part. Our metadata is an structure. You can see here we declare a public structure called program metadata, and we implement the metadata that it's on the G meta. Now, when you see this, G meta, GSTD, those are the libraries implemented on the Gear protocol side just to provide all the functionality to interact with smart contract. So in this case, the metadata, it has all the functionality that you need to know and you need to use in order to interact with the metadata. Okay, so we are implementing our metadata in our structure. And as you can see, we have different methods: init, handle, reply, others, signal, and state. The init is the part where once you initialize your smart contract, if you are providing information, then you need to explain here in your metadata structure if you are gonna send or and receive information in the init method. Then that's why you use this structure. This data type in out, it's saying that you're gonna receive a string and you're gonna return an empty data. Okay, so in out and the init method, it says that my smart contract will receive a string. Just remember this. Handle, the main method on our smart contract. Once the smart contract is ready to receive information to process events, then we need to declare here in the handle what information I'm gonna send and what information I'm gonna return. So I'm gonna send the TMG action and I'm gonna return the TMG reply. Let's see what is this structure. In this case, it's an enum. We can see it here. And we need to declare the proper attributes in order to say to our compiler that we will use this enum and we will encode at the code or a structure. This is the way it sends the information to the network and the other side understand what information we are sending. Okay, so my TMG action implements different kind of implementations. Here, just let me tell you something about this smart contract. This is a Tamagotchi. So if you remember, maybe you had once in the past one Tamagotchi with you. It's digital animal that you can interact with. And this animal, it could be different kind of animals. Then it has a name, an age. You need to provide food. This Tamagotchi needs to sleep. It's a digital toy, right? Okay. With this in mind, then if we see here the different actions that we can use, we can send an event for a name, age, fit, play, sleep, and TMG info. So this is the way a user or another smart contract interact with my smart contract, because once when I send a name, I need to return information related to this action, and it's going to be the TMG reply. Okay, so if I request the name, then I'm going to return the name as a string. If I'm going to request the age, I'm going to return the age as an unsigned integer 64. This it is because the time in my smart contract, it's a timestamp. Then is the milliseconds that has my Tamagotchi. And with some kind of calculations, we can have the years, months, and days that my Tamagotchi has, and this is the age. Okay, some calculations related, Unix, dates, timestamp. Okay, then fit. If I send the event to fit my Tamagotchi, then I'm gonna return the fit reply. First, I need to execute one fit process, and after I will return that my Tamagotchi has been fed. Okay. The same with play, sleep. It's those are actions that I'm gonna send to my contract, and my contract will execute some calculations to provide this to my Tamagotchi in the digital contract, and I will return the same information once I execute the action. Okay, and look at this structure. The TMG info, when I send the TMG info, I am trying to get the Tamagotchi information. So I will return to the user TMG structure with the owner, which is an actor ID. Okay, do you remember again the actor model? Well, once you want to interact with your actors and to the ecosystem, you need to specify the actor ID. It's a unique identifier ID. It's a unique ID, and you can use it to send and receive information. Just providing the actor ID to your structure. And on the other hand, also I'm gonna return the name and the date of birth. Okay, I guess that it's enough to understand the implementation of your metadata. You have more methods here, but we will use only the another thing, another method called state. Then what am I gonna persist in my smart contract? Then here say that I'm always return a Tamagotchi structure, and we can see here the structure. Tamagotchi structure has a name, the name of my Tamagotchi, has a date of birth, so to understand the age of my Tamagotchi, the owner, who is the owner of the Tamagotchi with an actor ID, and information related if the Tamagotchi already it's already it's it, if the user provide enough food for the Tamagotchi, then the Tamagotchi is fit, and if it's entertained, if it's rested, and all that. Okay, this is the state, and this information is the one that will be persisted into my smart contract. So I can use it whenever I want, and we're gonna see where and how the state is persistent on my main contract. Okay, let's move then to my main contract. You can find this implementation in the source directory lib.rs, and you will see code that initialize just the first interaction with the Tamagotchi, the hunger, the boredom, the energy. This is just an initialization. And let's see here, we need to find the static mutable. This is our variable where the state it's going to be saved. We call it Tamagotchi, and it's an option because we want to manage whether the Tamagotchi variable, which is a static mutable of Tamagotchi data type. Option will help you to understand if this structure has information or not. So at the beginning, our state, it's empty. That's why we initialize in this way. And something interesting here about this, once you save information into your smart contract, you need to keep in mind that some information is saved and some information is not saved, is not persisted between calls. And we are using here the static space of the memory. Then the static space, the static variables are saved into the smart contract. So it's persisted into the memory. But if you use internal variables, like let's see, for example, this, that here we're using a function, and inside a function we are creating a variable called auction. This is saved on the stack, and the stack is not persisted between calls. Okay, that's why we have our state declared as this way. So all the information that we want to persist must to be static to be persisted. Then, okay, this is our main structure. This is our state, the Tamagotchi. And let's see the handle method. Do you remember I told you that the handle was the more important part? Once you want to interact with your smart contract, then you can see it here. Handle, it's ready to receive messages, and Once a message is received, we can get this message with message load. Okay. Then we load the payload. The payload is the information that we send between smart contracts or between the front end and the smart contract. It's all the information that I want to provide to my smart contract in order to understand my events and execute some actions. Okay. Then I load my payload, and we save it here in a variable call action. It's the type TMG action, and we explain what different actions we can have. We can have a name, age, feed, play, sleep, and TMG info. So as you can see, we only try to understand what kind of action we are receiving with a match. And once we know what kind of action we have, then we implement the all the commands that this action needs to be executed, and after return something into as a result, right? Then when I want to know the name of my Tamagotchi, I don't execute anything but the reply, because I'm gonna return the name of my Tamagotchi with TMG, with the name and using the TMG name. Okay, then that's it. And if I receive some kind of error, I implement the expect, just to be sure that this function won't return an even. But if return an error, sorry, but if return an error, then we need to know how to manage these errors. That's the reason why we implement the expect. Okay, and the same with age, feed, play, sleep, and the info. So you can see this is a really easy way to implement normal functionalities. And for those who understand how to code in Rust, you will see that this is pure Rust. Okay, just we interact with some libraries and we implement some attributes, but it's Rust. That is the easy part. Once you understand the programming language, you can come and create your own smart contract really easy. Yeah, obviously you need to understand the basis of a smart contract and the basis of blockchain. Then you will be able to create your smart contract pretty fast. Okay, let's start with the compilation, because this has more code, but you will have the repo and the presentation you can check, and you can access and take your time to read the code and modify if you want to do something different. Then let's start with the compilation process. Here at the bottom, you can see a terminal where you can put your commands. Okay, just I'm gonna check that everything's fine here. Yeah, okay. Let me read some messages that we have here. I can. Do you participate in Vara challenge? Pre-crowd loaded here. Change big waving. Message from audience will display here. Oh, okay. No messages yet, so I'm gonna answer at the end the questions if you have one. Let's move on the compiling process. Okay. Well, my code is ready. On the left side, we can see different files that will help me to compile. We have the cargo tom L. It's the file that we use in order to provide information related to my compiling process. Okay, we're gonna create a library, which is a package. And this library has a name and some instructions for my variables inside the workspace. Let's see here. Before to compile, let's understand that we have different libraries that we will use on our smart contract. GST is the standard year library. So everything you need in order to interact with your smart contract, sending, receiving messages, will be implemented in this CRAT, GSTD. Okay. Then if you want to convert your Rust binary into a WebAssembly binary, you need to implement this, the Gear WASM Builder. So it's the CRAT that will help you to convert your dynamic library into a WebAssembly file optimized. And this instruction is used to provide information related to dependencies, but also you need to implement one file, this build.rs. Okay, if you don't have this file, then the compiling process won't generate your optimized wasm file. Then you just describe here that you're going to use the crats and you're going to use the method build with metadata, and you pass the metadata that you declared before into your IO directory. Okay, okay, let's go back into the cargo toml. And gmeta, it's the library, the CRAT that you use in order to implement the metadata. So as we are using metadata in this contract, we are uh, adding this line into my workspace dependencies. And scale info, it's CRAT just to implement the encoding and decoding into my smart contract, and some specific data types to interact with them with my main structures. And also the same parity scale codec and scale info are both crats that are used to interact with this kind of functionalities. And at the end, we only add our IO directory because we want to compile everything together, right? Okay, we are gonna use make, and I'm gonna explain why. The first command is make init. You can see on the left that we also have a make file. So cargo, yeah, is the the program that we use to interact with the packages of Rust cargo, the package manager. Then we can use cargo to execute different instructions. But also, if you want to make it easier and avoid to learn by heart all the commands, then you can implement the make. Using the make file, you will declare here different commands that you want to use, and this make commands will execute the internal commands. Like, for example, make init. Before we execute, let's search. We'll find the init here and we'll execute this. So it's exactly the same if you copy and paste all these commands separate, but in this case we're going to use the make init process. Okay, so this is installing the dependencies that we need for our smart contract. Then it's ready, and now we're gonna compile, make build. Let's check here the instructions. Okay, it's gonna compile my workspace, and also it's gonna show me where is my WebAssembly file. Okay, then let's execute this process. It lasts some minutes depending on your internet, a little bit of your machine. This process is not running on your local machine, right? Like we are using Gitbot. Once you start Gitbot instance, do you remember that the first screen shown it was choose the server? Well, first the repo, choose the repo, and the third option it was what kind of server do you want, and you have different options: the normal server, or you need more resources because you are interacting with a huge application, then you can use another server more powerful. Then all these instructions are running on the server side, okay, not on your machine, but you're seeing the commands and the result as if you were executing in your browser, but it is not. The nice thing is that even though that the processing is on the server side, when it ends, you will see here your output files. We will have our optimized WebAssembly file, and we will have also our metadata file. Those are the files that we will need in order to upload our smart contract into the blockchain. Okay, so we're almost done. I'm gonna check if we have some questions so far. Guys, girls, if you want to ask something, whatever related to the process, related the smart contract creation, related to technology, please feel free to send a message, and I can read here. And also, I will be able to explain more information. Oh, let's check here. Cannot find value name in this scope. I believe that I changed information related my smart contract. Let's check. Let's go where the error is found. Here it says that is in the lib.rs 129. Let's check this line. Then let's go 129 here. Okay, let's see. I am passing. Okay. Let's understand the code. As you can see, we're using a name variable, but the variable name is not declared. It's commented the line. Okay, so we can do this. We can uncomment. In fact, we have different to-dos in this workshop. Just please go into the repo and you can read and execute the necessary in order to make your smart contract works. Okay, then, okay, that was the error because we are using the name as init parameter to create my Tamagotchi structure, but the name was commented. Now that I uncomment my name variable, we can see that we set the name here. So you can put the name you want, uh, Luis Tamagotchi. And let's execute again the make build process. And that's it. We have our opt wasm file and we have our state wasm. Just to read the state in a specific way. That's the use of state wasm and our normal WebAssembly file. Let's check here. On the left side, you will find the target. You also have the wasm3209 directory and release. You can see here our tmg opt wasm. Let's right click and download. And also tmg meta.txt. This is our metadata. Okay, we have here two files. Just remember the name is tmg-opt2 and tmg-meta2.txt. Again, the opt wasm is the file that we need, optimized wasm, and the metadata. So as you can see, the metadata is a file with hexadecimal information. So yeah, I'm pretty sure that you don't know what it is. You need to use converters in order to understand, but you don't need it. It's I already explained. It's our structure or data types that we will share between the smart contracts. And here is described this data type. So it has the format that our smart contract will understand. Yeah, we only need to understand the code, but these files are managed by our smart contract. Then it's okay. Where can we upload our smart contract? Check. We need to enter into the idea.geartech.io. And we can see here our main UI. In this gear idea, you can upload your smart contracts, you can read the state, you can send messages, you can check the mailbox for the smart contracts and explore the transactions and different things. So let's start connecting our wallet. This platform is ready for you to connect with different wallets like Polkadot.js, Subwallet, Talisman, Encrypt. Then just make sure that you have your wallet installed on your browser. Whatever you want, it's okay. So as we can see here, we have the option to connect four different wallets, and all are disabled. Let's click on reload just to make sure that our application it is our wallet. Okay, I log out just to make the process from scratch. Then again, let's click on connect, and you can click on Polkadot.js, for example, is the extension that I have already on my browser. And you have two options, Tamagotchi account or demo. Those are mine. You can create your own here. Let's show you. Yes, here you can click on plus, create new account. You can create account here. You need to save this mnemonic, because if you want to recover your account after this, the only way to make it possible is remembering these words. But let's be honest, maybe you won't remember it, so write it on a paper or save it wherever you want, but save it. Here, click the copy to the clipboard, and I have saved my mnemonic sit safely, so I will be able to put a name to my new account. Let's put Polkadot Workshop, and let's put our password. Okay, we have here our new account. So can you see here, Polkadot Workshop? And let's click on it. Well, you're almost ready, because you don't have enough gas to upload your smart contract. Then you need to find a faucet. Sometimes it's a kind of tricky this, and you need to ask into Telegram groups or Discord groups, where can I get my Vara's tokens? Here, you just need to see on the top of your window here this icon, get this balance. It will provide you 100 Varas every day, just once per day. Okay, so this is the faucet. You need to click get test balance, and you just need to follow what the captcha says. So please click on all entities similar to the following pattern. Okay, it seems like those are similar to the pattern. Then also this and this. Let's verify. And we just need to wait, and we're all set. 100 Varas. So we are ready to upload our smart contract, because we have no gas. We have tokens to pay our gas fees. Click on upload program, select file, and it was the OPT. Just let's go here and remember the names. It's TMG Meta, okay, and TMG OPT, right? TMG OPT, the two. This was the one that we compile. And on the right side, it detects my metadata. If you don't see this, but instead you see a button that say upload metadata, just click on it and select your metadata file, and you will see this, exactly the same information. Okay, here we can see the init method use an input string. The handle method, the input is the TMG action and returns the TMG reply. It's exactly the same that we check on the metadata structure, right? And on the other hand, the state, it's gonna return a Tamagotchi structure. Nice. Then the only thing we need to do before to upload our smart contract, it is to set the name. This is generic name you can set just to identify on the platform your smart contract, but it's not the way we identify the smart contracts into the ecosystem, because every smart contract will have an actor ID once it's created into the blockchain, right? Then let's put here Tamagotchi contract is the name of my contract, not the name of my Tamagotchi. But we can add here in the str attribute, we can add my Tamagotchi name. I'm going to explain this in the code, but just give me one sec. Oh, sorry. Let me stop my presentation and let me share with the idea. Here, okay. Well, I guess that I did this process without you were not aware about my window, right? Okay, sorry, I'm gonna do it pretty fast again. Just it could be for you really easy. Just remember the website is Idea Gear Tech.io. You can see it here. Let me double check that you are seeing. Okay, you are not seeing this, but I can send to the chat. Okay, I'm gonna share. Just you have the link, but just put idea.gear/tech.io, and you will enter into this platform. Okay, so let's connect my wallet, Polkadot.js. Let's choose the account that I create for this workshop, Polkadot workshop. And I have here 100 Varas. Just let's do again the process just to see that it throws an error, because remember that you can only do this once per day. Okay. So you can see here, limit to transfer balance is reached for today. Then don't worry, because we have 100 Varas. I'm pretty sure that if you do exactly the same process, you will have also 100 Varas. Then you are ready to upload your smart contract. And let's do it again. Upload program, select file, and the TNG2 OPT WASM, remember, is the OPT version with our metadata here, describe it with our init, handle, and state. And here in the name, we're gonna set the name of my smart contract. Let's put the Prodigy smart contract. And here in the str, we're gonna put the name of our Tamagotchi. Lara Gochi, it's gonna be the name. And before to upload the program, we need to calculate the gas. So we need to click here, calculate, and we are done. Okay, we are ready to upload our smart contract. Just click on upload program. You can see here the details of your transaction. Just click on submit, and you just need to sign your transaction. Click here and remember my password for the next 15 minutes, just to avoid that this window shows up every time that you are signing a transaction. Okay, so the smart contract is being sent to the blockchain. We just need to wait for the process of the gear block generation, and after the metadata and all that stuff, then we're all set. We can click on programs on the left side, programs, and on the right side, my programs, just to find faster my programs. And we can see here, the only smart contract I have on my account, because I just create this, is Prodigy smart contract. What can I do here? I have my smart contract, and I can click on this just to check all the information I have. On the right side, we have different messages. We send a message and we receive an answer of this message. It's a message reply. And one interesting thing is that we will be able to send messages to my Tamagotchi, but also read the state. Let's check. Read the state, we click on read state, read full state, and read. There you go. This is all the information that we persist inside my smart contract. So it has the name, Luis Tamagotchi. Do you remember that I set this name in the code? When I uncomment the variable name, yeah, it's here. It was initialized my smart contract Tamagotchi with the name I set into my variable name. Then we have it here. And all the different parameters of my Tamagotchi, like a date of birth. This is a big number. It's a timestamp in milliseconds. The owner is the actor ID or the address of the owner. In this case, it's my address. And fed block, entertained, rested, all those are initial parameters that we set to interact with my Tamagotchi. Okay, and let's finish this workshop sending messages to my smart contract. So you will see that you can interact with your smart contract in this application. And before to implement your own front end, you will be able to test different methods of your smart contract here. So let's send a message. One of the methods that we implement, do you remember, is name, age, feed, place, sleep, and TMG info. Let's let's ask the name of my Tamagotchi. So we're gonna send a message, okay, to my smart contract. The smart contract will receive as a payload and will save it into an action variable. And with the match, we'll understand what action I am sending. So when I ask the name, my smart contract will reply with the name. Okay, let's click on calculate and let's click on send a message, submit, and sign the transaction. We just need to wait in order to send this message, and it's done. So we just need to go to the smart contract on the platform and check the messages. Let's see. We have here Prodigy smart contract. Also, if we filter with my programs, we will see here the same. And check. We have here other two messages. This one that I send the payload name, and this one, it's the answer. I have the name as Luis Tamagotchi. So in this way, you can interact with your smart contract, sending, receiving messages, implementing whatever you want. This is a single Tamagotchi smart contract, but even though that is single, you saw that create your code on Rust. It's really easy, and you will have a smart contract pretty fast. So this is all on my side so far. If you have one question, just feel free to send it. I can read you. I don't see any questions here on my chat, but maybe we can wait just some seconds before to end this session. Okay, let's wait a little bit. Just feel free. I'm gonna share also my presentation, because if you want to keep in touch, you will be able to do it. Just give me 1 second, and I can stop my screen. And also, okay, now you can see here again my presentation and my information. So thank you for your attention. My mail is Ramirez at gear.foundation. And on the right side, you have our Twitter account and the GitHub account, the GitHub of the Gear Foundation. Then feel free to tell me whatever you want. Send me a message if you want to understand something. Um, Sabina, no questions. Okay. Well, thank you so much. And thank you, Metagaming. Great explanation. Thank you, Liz. Thank you to you. Okay. If you are building on Vara Network in this hackathon, then feel free to contact me and write in the Discord channel, of course, just to ask for help, and we will be there. Thank you so much. That was everything on my side. I